All right, let's get into it. Today, we are cracking the code on some seriously powerful math secrets. We're talking exponents and radicals. And you know what? We're going to do it the lazy way, which, trust me, is also the genius way. Now, really, think about it. What if I told you there's a secret way to do way less writing in math class, get your homework done faster, and still look like a total genius? Well, that's exactly what this is all about. This isn't about working harder, it's about working smarter. Okay, check this out. Let's say your teacher asks you to multiply 3 by itself 4 times. You could write it all out like this. But yeah, our little parakeet friend here knows what's up. That is a total snooze fest. It's long, it's repetitive, and it's just way too much work. That's the rookie move. But hey, we're not rookies. Nope. We're here for the math life hacks, the shortcuts that make everything easier. So let's look at a much, much better way to do this. And boom, here it is. This little thing is called an exponent. Instead of writing 3 4 times, we just write one big 3 with a little 4 floating up top. The big number, the 3, that's called the base. Simple enough, it's the number you're multiplying. And that small number, the 4, is the exponent. It just tells you how many times to write down the base. Why write 4 numbers when 2 will do? Now here's where it gets really cool. Exponents have their own set of shortcuts. Seriously, these are like the shortcuts to the shortcuts. So let's put together our official Lazy Genius cheat sheet. And you know what? Our parakeet guide is 100% right. Once you're using exponents, you almost never have to do any actual multiplying anymore. These 4 rules let you solve problems just by adding or subtracting the little exponent numbers. It is awesome. So here are the 4 golden rules. If you're multiplying 2 numbers that have the same base, just add their little powers together. If you're dividing, just subtract the powers. If you've got a power raised to another power, you just multiply them. And my personal favorite, anything, and I mean anything to the power of 0 is always just 1. How easy is that? Okay, so we've learned how to build numbers up really fast with exponents. But what about going backwards? Is there like an undo button for exponents? Oh, you bet there is. So first, let's talk about a kind of weird one, negative exponents. Now this looks scary, but it's actually super simple. Think of a negative exponent as an elevator ticket. All it does is tell the base number to move. If it's on the top of a fraction, it moves to the bottom. If it's on the bottom, it moves to the top. Notice the number itself doesn't become negative. It just changes floors. Okay, time for the next secret identity. If you ever see a fraction as an exponent, don't freak out. It's just a root wearing a disguise. The number on the bottom of that fraction tells you exactly what kind of root it is. So 16 to the power of 1/2, that's just a super sneaky way of writing the square root of 16. And that brings us to this symbol's official name. It's called a radical. And really, you can just think of it as the special tool we use to undo an exponent and figure out what number we started with. So yeah, a radical is basically the official undo button in math. Just like hitting undo on your computer gets rid of what you just typed, a square root gets rid of a square. The square root of 25 is 5, because 5 squared is 25. A cube root undoes a number that's been cubed. They're perfect opposites. Okay, cool. But what happens when you get a radical that isn't a nice, easy, perfect answer? Well, my friend, then it's time for a jailbreak. So imagine the number inside that radical sign is locked up in a little house, or a jail cell. Our mission is to break out as much of that number as we possibly can. And the secret key? It's finding perfect squares hiding inside the number. Any perfect square, like a 4 or a 9 or a 16, gets a key to escape. Let's try it. Take the square root of 18. Not a perfect square. But wait a second. Hiding inside 18 is 9 times 2, and 9 is a perfect square. So the square root of 9, which is 3, gets to bust out of radical jail. The poor little 2 isn't a perfect square, so it has to stay behind. Our final simplified answer is 3 times the square root of 2. Now listen up. This part is super important. When you're working with radicals, you can multiply pretty much anything. The square root of 3 times the square root of 5, no problem. That's the square root of 15. But you absolutely cannot add or subtract them unless they are like terms. That just means the number inside the radical has to be the same. You can't add the square root of 2 and the square root of 3. It's like trying to add apples and oranges. It just doesn't work. And now for the ultimate pro-level lazy genius move.
Remember how a root is really just a fractional exponent in disguise? Well, you can totally use that to your advantage. If you ever get a really ugly, complicated problem with radicals, just switch it back into an exponent and use that awesome cheat sheet we made earlier. This one formula connects everything we've talked about.
So, right about now, you might be thinking, okay, these are some cool tricks for my math homework, but am I really going to use this in real life? Oh, absolutely. Let me show you. See, this isn't just random stuff for a test. Exponents are literally the language of growth. This is how we calculate how money in a bank account grows over time, how a population of bacteria grows in a science lab, or even how fast something is accelerating in physics. This is the math people use to understand and predict the future.
And that's a wrap. Here's your too long didn't read summary of everything. Exponents are for multiplying stuff over and over. Negative exponents flip things in a fraction. Fractional exponents are just secret roots. And radicals are the undo button. Go ahead and screenshot this right now. It is your ultimate cheat sheet. And just like that, you did it. You are now officially a lazy genius when it comes to exponents and radicals. You know the hacks, you know the shortcuts, and you know why they actually matter. You've definitely earned a break. So, I'll just leave you with this one question. Now that you have these new math superpowers and you understand the code behind how things grow and change, what future are you going to predict?